Quantum theory, also known as quantum mechanics or quantum physics, is a fundamental branch of physics that provides a theoretical framework for understanding the behavior of matter and energy at the smallest scales, typically at the level of atoms and subatomic particles. It has been an incredibly successful and accurate theory, revolutionizing our understanding of the physical world. Here are some key principles and concepts associated with quantum theory. 1. Wave-particle duality. One of the central ideas in quantum theory is the concept of wave-particle duality. This means that particles like electrons and photons can exhibit both wave-like and particle-like properties. They can behave as if they are waves, with characteristics such as interference and diffraction, or as particles with definite positions and momenta. 2. Quantization. Quantum theory introduces the idea that certain physical quantities, such as energy levels and angular momentum, are quantized. This means they can only take on discrete, specific values rather than continuous ones. For example, electrons in an atom can only occupy certain energy levels, or shells. 3. Uncertainty principle. The Heisenberg uncertainty principle, formulated by Werner Heisenberg, is a fundamental concept in quantum theory. It states that there is a fundamental limit to how precisely one can simultaneously know the position and momentum of a particle. The more accurately you measure one of these properties, the less accurately you can measure the other. 4. Quantum states and wavefunctions. In quantum theory, the state of a system is described by a mathematical function called a wavefunction, or quantum state. The square of the magnitude of the wavefunction provides the probability distribution of finding a particle in a particular position or having a particular momentum. 5. Superposition. Quantum particles can exist in a superposition of multiple states simultaneously. This means that a particle can be in a combination of different positions or energy levels until it is measured or observed, at which point it collapses into one of those states. 6. Entanglement. Quantum entanglement is a phenomenon where the properties of two or more particles become correlated in such a way that the state of one particle is dependent on the state of another, even when they are separated by large distances. This phenomenon is famously described as spooky action at a distance. 7. Quantum mechanics equations. The mathematical framework of quantum theory is based on a set of equations, including the Schrödinger equation for non-relativistic quantum systems and the Dirac equation for relativistic systems. These equations describe how quantum states evolve over time. 8. Quantum mechanics and quantum field theory. Quantum mechanics forms the basis for understanding the behavior of individual particles, while quantum field theory extends these concepts to describe fields, such as the electromagnetic field, and their associated particles, like photons and electrons. 9. Applications. Quantum theory has had a profound impact on various scientific and technological fields, including quantum computing, quantum cryptography, quantum optics, and quantum teleportation. It also underlies the functioning of many modern technologies, such as semiconductors and lasers. Quantum theory has been extensively tested and has withstood the scrutiny of numerous experiments, making it one of the most successful theories in the history of physics. It has reshaped our understanding of the microscopic world and continues to drive groundbreaking research and technological advancements.